All right, last question, question J. Which of the following could be the sketch of a curve px plus py equals to 0 for some polynomial p? Okay, and then we've got 4 graphs. Cool. Okay, so what's special about the polynomial on the left-hand side here? Is a polynomial in 2 variables, fine. What's special about it? It's a symmetric polynomial, right? Very nice properties in mathematics for these. Okay, can't write symmetric polynomials. All right, so that means that if I swap, okay, no matter how I permute the variables, okay, if I swap the x and y, for example, it's going to still be the same polynomial, right? And that probably sounds familiar because, when you do inverse functions, for example, right, you swap the y and the x's, right, and then you sort of reflect on the line y equals x to get the inverted graph, right? So same here. If you have a symmetric polynomial, right, and you take the inversion, okay, or mirror at y equals to x, then it should give you the same graph now, right, because it's a symmetric polynomial. So let's see. If you take, for example, y equals to x, here, 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 here. So if you reflect it there, you should get the same graph. So D is good, C is good, and B seems to be okay as well, but A is already no good, right? If you flip the quadratic, then the quadratic is gonna be to the right, right? Not opening up, but opening to the right. Okay, so A is bad. So not this, not this, not this, and not this. Okay, so answer is already option C. Okay, but it says C and D, right? It says not A or B. Okay, so why is B also not okay? Let's have a think. All right, so let's just think about a random segment of the graph. Okay, so say the graph is this chunk. Yeah, think about this chunk. Cool. Okay, so what's special with this chunk? This chunk, p of x is constant. Is constant for this chunk, right? Because surely you're using the same x coordinate, right? So if you have the same x coordinate, then if you chuck that x coordinate into the polynomial, it always gives you the same value, right? So that means that p of y is constant over this interval too. Over this interval. Over this, yes, y interval, I suppose. Good, okay. So if py is constant over this interval, okay, then it must be a constant polynomial, right? Nothing else. Okay, so if py is a constant polynomial, then the graph should look like what? This line should be extended upwards and downwards, right? Now all the y values should be able to satisfy this equation anyway, right? Because py is constant, so it has no y dependence. So the graph should be the whole line, right? You should extend it up and down even, right? But this graph is not extended, right? So that's why B is no good. But either way, if you knew that A was no good, then you have the answer as well. All right, there we are.